Alright, in this video we are going to look at two examples where we are asked to determine if the graph of the function we can see is a one-to-one function. And then if we determine that it is, then we can graph the inverse of that function and find the domain and range. Okay. So in order to do that, we have to understand what one-to-one function is and what the easiest test for us to use in order to determine the one-to-one function. Okay. So a one-to-one function is essentially a function that if you have different inputs going into your function, then you should have different outputs coming out of your function. In the reverse psychology of thinking, that same idea would say that if your outputs are the same, then your inputs are the same. Okay? So when we're looking at a one-to-one function, essentially what that means is we are looking for a function where your x value is pairing with one y value. Okay? Now, the one-to-one function is thinking specifically about the inverse of the function you've been given. So what we have, say in this first graph, is we have the graph of an original function, and what we want to know is if it's one-to-one. Okay? So when we look at it, if you recall, in order to determine if a function in general is a function or a graph is a function, you would drop your vertical line test. Your vertical line test is looking for when you drop a vertical line into your graph, like say this one, and let's say we went ahead and dropped a vertical line, I don't know, right here. And if we drop that line kind of all the way down, what we're looking at is how many times that vertical line were to cross your graph. And in this case, it crosses at only one place, which means the graph is a function. To determine one-to-one, we have to look at what's called the horizontal test. Now, the horizontal test is a test where you are going to drop a horizontal line into your function. Okay, so for example, I'm going to try and make this as easy as I can. So let's go ahead, let's move it down here. And I'm going to drop this horizontal line. I'm going to go ahead and kind of make it somewhat thick dashed line. So there's my horizontal test. Now, if I'm a one-to-one function, then my horizontal test will only cross my graph at one place. However, not only do I cross here, I also cross over here. My horizontal test in this case is going to cross paths in two locations. What this means is that this function fails the horizontal test. Failing the horizontal test automatically means that your function is not a one-to-one function. Because I'm not a one-to-one function, what this actually means by definition is that the inverse is not a function. Since my directions only wanted me to graph the inverse if we proved one-to-one, there is nothing more to do in this graph because I failed the horizontal test. Okay. Now what happens if we're given a graph that passes? So if you look at this one, you can see that clearly this is going to pass that horizontal test. No matter where I were to drop my horizontal line, it's only going to touch at one place. So because this one passes your horizontal test, by definition, this means that your function is a one-to-one function. At the same time, that also means that your inverse is a function. Now, notice I haven't been given any equations, I haven't been given anything specific about this, so I have to be able to graph the inverse based on the graph itself. To do that, I just simply have to identify some points. So if I look, I can see that I have a point here that is directly at an intersection. I've got one here, and I've got one here. So I can use these 3 points in order to make my graph. So the first thing I need to do is identify your points. So let's call this A, B, and C. Okay. So when I'm looking at these, there's a few things that I need to know. First of all, I know that when I'm looking at point A, I am going to be, let me scoop this up so you can see. I'm going to be right here, and this is the point -1, 0. At point B, I'm at the point -2, -1. And at point C, I'm down here. I'm at the point, if you count, this is -5 down -2. So this is my original, okay? So if I'm trying to take notes, this is my original function and the points that goes with it. Well, if we use that definition for my inverses, I can find my inverses. So my inverse, again, I would have point A, I would have point B, and I would have point C. So if I look at A, my inverse here would be, if you remember, you're going to switch your X and Y coordinate. So instead of it being -1, 0, my inverse is going to be at the point 0, -1. For B, instead of it being -2, 1, that inverse is going to be -1, -2, which makes my C point -2, -5. I have my 3 points here, so I can go in and graph those. So my first one was at 0, -1, so that would be this point here. I have -1, -2, which is this point here. And then -2, -5, so 2, 3, 4, and 5, that's this point here. Then again, I would kind of connect my dots, and so I've got these kind of coming through, and this coming down. Okay. Now, if you remember, inverses are always graphed and reflected over that reflection line. So if we were to take a quick look, remember the reflection line is the line that's going to cut straight through my origin here. So I can go ahead and drop that in just so you can see real quick. Okay, so there is your actual reflection line. That is what this is called. And if I were to fold my graph along that line, you would notice that these two graphs here would completely line up with each other. Okay, so again, this is the reflection line. And that's the line y equals x. Okay, and so we use that line in order to help symbolize my functions. Now with that, I also need to look at the domain and the range of that inverse. So I'm looking here at this pink-ish graph. And so when we look at the domain, remember your domain has to do with the x values. So essentially we're taking a walk along that x-axis and we're taking a look at our graph. So here I've got this arrow going down, so my domain for my graph is going to go from -infinity, and notice my graph stops here when x is 0, so it goes up to 0. 0 is included, so I use a bracket. I can also look at my range, which is obviously the y values. So here again, my arrow is showing me that I'm starting way down here at -infinity, and it's going to travel all the way up to where it stops. So the highest my y value is going to get is the -1. So here this goes to -1. Again, it's included, so I use a bracket. And that is everything that you need to do in order to check and see if a function is one-to-one, graph the inverse function if it has one, and then identify those domain and range pieces. Okay? So if you have any questions about one-to-one functions or using the horizontal line test, please feel free to let me know. Otherwise, I do hope you enjoyed this video as much as I enjoyed making it, and I'll see you next time.